Today in class, we are going to review solving systems. Please make sure you have a half sheet of paper out on your desk because we will be doing some problems together and I will be collecting them. The first method for solving a system is solving by graphing. Here are some examples. I have two equations that I need to graph and figure out where they intersect. So I need to look at their slope and their intercept. So I rewrote the equation over here. 1 is the slope and 3 is the y-intercept. So I want to graph my y-intercept first. So looking at the graph, I go up 1, 2, 3, and then I'm going to apply my slope. My slope is 1 over 1. So that's up 1, forward 1, up 1, forward 1. And then I just continue to make my dots. The second graph has a slope of 3 and an intercept at 1. So again, I'm going to do my intercept first and then apply the slope. So the slope is 3 over 1. And my intercept is at 1. So I'm going to start at 1 and I'm going to apply my slope. So that's up 3, forward 1, and that's where I hit. An equivalent slope would be negative 3 over negative 1, so that would take me down 3 and backwards 1. And now I connect my dots and you can see where my point of intersection is. So I'm going to write that coordinate down. It's forward 1, up 4. So the solution to this system is the point 1, 4. Let's try another one. In the first graph, these are already in the first equation, these are already in slope-intercept form, so I can figure out what my intercept is. And then my slope is 2 over 1. So now I can apply my slope. So that's up 2, forward 1, up 2, forward 1, or down 2, backwards 1, down 2, back 1, down 2, back 1. In my second equation, I have an intercept at negative 1, so I need to start down here. And then applying my slope, I have 3 over 1, so that's up 3, forward 1, up 3, forward 1, and then I hit. And now I'm going to extend my lines and connect my dots. And my intersection point is here at the point 2, 5. So this is solving a system by graphing. The next method we're going to review is substitution. The directions say solve each system using substitution. So during class when I taught this, we talked big box, little box. So we noticed that x is already solved, so that's going to be my big box, and I need to plug it in the second equation into that little box. So we know what x is, so we're going to substitute it into that second equation. So it becomes 2y equals y plus 2 minus 1. So in blue, that is what we plugged into that little box. And now notice we've combined both equations and we have one variable. So now we can solve. So I'm going to subtract y, and I get y equals 2 minus 1, so y equals 1. So that's the first part of our solution. So now I need to plug in and find the other part. So if y is 1, 1 plus 2 is 3, x is 3. Just a reminder, you haven't written anything on your white sheets yet, unless you want to. Let's try another one using substitution. Number 4. I noticed in the first equation that y is already solved. And in the second equation, y is already solved. So if the blue is equal to y and the purple is equal to y, they're both equal to y, so then they have to be equal to each other. So 3x plus 5 equals x plus 3. And now I'm solving my equation. And I get 2x plus 5 equals 3. (2x) equals negative 2. So x is equal to negative 1. And now I need to plug in to find my y value. So I could either plug that into the blue or the purple, but I think the purple is going to be easier. So -1 plus 3 is +2. And there's my solution. On your sheet of paper, I'd like you to try number 5 on your own. Please pause the video while the students work. When everybody's ready, the answer will be on the video. Here's my solution. I put my big box around what x is equal to, and then I'm going to take that big box and I'm going to plug it in for x. So now I've combined both equations into one, and now we have one variable. The way that this problem is different from the other two is that we have to distribute that 3 through. So I get 3y plus 6. And then I have to combine these like terms for my constant, and I get 5. And now I can solve. So I'm going to subtract 3y from both sides, and I get -5y equals 5. Divide by -5, and I get a -1 for my y value. Then I can go back up top and plug it in. So I get -1 plus 2 is 1. And that's how you solve a system by substitution. The last method that we're going to look at today is elimination. Elimination means that we want to eliminate one of the variables. So we want to get opposites in one of our terms. So in my x's I have a 3 and a 2. In my y's I have a 4 and a -4. So I already have opposites. Once you have opposites, then you can combine your equations together. So I'm going to add, I'm going to get 5x. 4 and -4 make 0, so they eliminate. And then 31 and -6 make 25. So I have just solved for half of my answer. My x value is 5. And now I need to plug in. And it doesn't matter which equation I plug into. I will plug into the bottom one. So I get 2 times 5 minus 4y equals -6. So that's 10 minus 4y equals -6. So I'm going to subtract my 10, and I get -16. Divide by a -4, and I get a +4. So this is solving a system using elimination. Let's try another example. We want to get opposites. In our x's we have a 4 and a 5. In our y's we have a 3 and a -2. So we have to make some changes. So do we think it's going to be easier to get opposites in our x's or in our y's? I think it's going to be easier to get it in our y because we already have one positive and one negative. So I'm going to multiply the top equation by 2, and I'm going to multiply the bottom equation by 3. And now I'm going to rewrite them. So my top equation becomes 8x plus 6y equals 16, and the bottom equation becomes 15x minus 6y equals 30. And now I have opposites, so now I can add, and my goal is to eliminate. So 15 and 8 make 23, 6 and -6 make 0, and 16 and 30 make 46. Divide by 23 and I get 2. So there's the first half of my answer. Now, I need to plug in and find my y value. So I could plug in to these two green equations, but my coefficients are high. Whereas the original black equations, the coefficients are lower because I didn't multiply them by a factor. So I'm going to plug in my 2 into the top equation, and I get 4 times 2 plus 3y equals 8. So that's 8 plus 3y equals 8. So if I subtract 8, I get 3y equals 0. Divide by 3 and I get 0. Now, on your half sheet of paper, I would like you to try this last problem. Make sure you find opposites. So in the top equation, we have a 3 and a 5. In the bottom, we have a 6 and a 4. So if we do opposites in the x, what number would we be looking at? You could do 12 if you want. Then you can multiply the top one by 4 and the bottom one by a negative 2. Then you'd have a positive 12 and a negative 12. Or you could make life easier for yourself and just do 3 times 6 and 6 times negative 3 and get 18. Otherwise, the third option would be to work with your 5 and your 4. So we could do 5 times 4, and we could do 4 times negative 5. And I think I've bypassed the easiest solution, so there is a fourth way, and it has to do with the 3 and the 6. So why don't we just take this and do what? You got it. Multiply by negative 2. So start this problem on your own. Please pause the video while the students work and show the answer when everybody's done. So I multiplied the top equation by negative 2, and I got negative 6x minus 10y equals negative 108. And I left the second equation the same. So I'm going to take those two equations because I have opposites, 6 and negative 6. Now I can add them together. So I get negative 6y equals negative 36. So 6 is my y. Then I chose to plug in 6 in my bottom equation. So 4 times 6 gave me 24. Subtract 24 for 48, divide by 6 for 8. So you should have 2 problems on your half sheet of paper. Please put your name on it, pass it all the way to the front. The next thing we're going to do is look at our worksheet. Please make sure everybody has a worksheet. Pause the video until you're ready. Here's what your worksheet looks like. 1 through 4, solve the system of equations by graphing. So 1 and 2 and 3 all are in y equals mx plus b. So let's try number 4 together. So remember from last week, this first equation, I just rewrote it down here, is written in standard form. So what we want to do is find our x and y intercepts. So to find our x-intercept, what we're going to do is plug 0 in for y. So if I plug in 0 for y, 2 times what is negative 4? Negative 2. So I can put a dot on my x-axis at negative 2. To find my y-intercept, I'm going to put 0 in for x. 2 times 0 is 0. So negative y equals negative 4. So y would have to be just a 4. So that's where my other dot would go. In my second equation, I can just graph by finding my y-intercept. So here's my y-intercept, and then applying my slope. Down 5, forward 1, down 5, forward 1. So we found our solution to be the answer, over 0, up 4.